So for today's experiment, we're going to be doing some video analysis. In particular, we're looking at carts on the air track. So I set up and recorded a bunch of video that looks like this. And then we're going to be using Tracker, which is a video analysis program. You can get it at phys.lit.org/tracker if you want to try it out yourself. But I'm just going to go through the analysis that I did to extract the position and velocity versus time for the cart on the air track. So once we have a video ready, we can open it in Tracker. So that'll take a minute to load up. And then what we're going to do is create a coordinate system and then track the motion of the object we're interested in. So we're going to be tracking the motion of the cart along the track. So what we really want is the x coordinate to be motion along the track. By default, Tracker is going to use x and y pixels. But what we can do is create a coordinate system and line up the x dimension with the track. So I'm going to do that by zooming in here, and I'm going to put the origin right here at the corner of the track. You can see where that's kind of sticking out. And then I'm going to rotate it so that it's along the track. So it looks pretty good, but if I zoom in, I can do it a little more carefully. Let's see. Here we go. And now I've got the x dimension along the track. I can hide the coordinate markers like this once I've got them set up. And then what I'm going to do is create a calibration stick that tells it how far these pixels are apart in the real world. And that's the reason these pink Post-it notes are on here. I put the top right corner of them 1 meter apart so that I can zoom in and place one end of the calibration stick on that corner. Go over to the other one. Let's see. And put the other end of the calibration stick on the other corner. And since those are 1 meter apart, I can then tell Tracker that's how far apart they are. And now the pixels here are correlated with physical distances in the real world. So now that we've got our coordinates set up and scaled, what I'm going to do is zoom in a little bit on our cart. And I'm going to create a new point mass, which is our way of saying there's an object we want to keep track of. I'm going to turn on the auto tracker. And then when I Control-Shift-click on the sticker here, we get this red circle is the region that it's looking at. And it's basically, I'm going to increase this a little bit in size. And basically what the program is going to do now is pattern match subsequent frames and look for this pattern. So you can see the template is what it's looking for. The match is what it's found. Those are the same in this frame because I just created the template. But if I go to the next frame with search next, you can see the template and the match start to look a little different. The match is kind of wiggling a little side to side. But as long as it stays centered, then our x-coordinate is going to track the motion of the object pretty well. So I'm going to go ahead and auto search, let this thing run, and we'll see how it does in terms of keeping track. You can keep an eye on the template and the match here. We can also kind of zoom out to see everything. And you see that red frame is tracking the motion of the cart pretty well. See the template sort of slowly evolving as it incorporates each subsequent match a little bit. And it's moving up and down a little, but in general, it's doing a pretty good job of keeping track of the X position. So we've got those coordinates coming in. Here, there's a graph of X versus T, and you can see we're getting a nice smooth parabola. It's not jumping around. As the cart's slowing down, stopping, and turning around, we reached a minimum in X. And since I set the origin of the coordinate system at the left edge of the track, and the track's 2 meters long, we expect all the values in X to be between 0 and 2. You can see that that's in fact the case. And we're speeding up now, coming back down. And just let this finish up. You can see I'm getting a table of values down here, and we're basically, once we're done, we'll export these to a text file so that they can be loaded into a spreadsheet. Okay, and we've basically reached the end of the video. So we can turn off the auto tracker. In the table, we can turn on some other variables. In this case, let's take a look at Vx. So we've got values there in meters per second. You can see the maximum is about 0.7 down here. And it starts at, okay, -3. These values seem pretty high. Well, take a look at the graph and see if we can tell what's going on. Okay, so there, this first part is my push. And this part here, we've got a pretty clean straight line in Vx versus T. You can see where it goes through 0 here is where the cart stops and starts getting positive velocity. So this looks like it'll work pretty well. I'll just export a data file, and we can take a look at that in the spreadsheet. So now that we've analyzed the motion, we can reset the video, and we can take a look. I'm going to put up 2 plots. So we have the position versus time and up here, and we've also got a graph of Vx down here. So we can play back the video and watch those graphs as we go. So starting out, right now I'm pushing the cart. You can see there's a big increase in the leftward velocity. And as soon as I release, the velocity starts decreasing. You can see it's negative here, but moving up towards 0. And we can look at the curvature and the position versus time graph as the cart is slowing down. And here's 0 velocity. We're coming up on that pretty soon. And you can see the cart slowing down and stopping right about here. And then the velocity starts going positive as the cart starts moving back to the right. This playback is kind of slow, but you can see we're about 1.5 seconds of video time away from the cart hitting the end. So just about now it's going to hit the bumper. We see a big spike of velocity goes back down to negative for the last couple frames because the cart turned around when it hit the bumper and went back to the left.